So we're going to take a look at this, and we're going to say, let's make this, instead of this say /24 here, all right, instead of /24, let's make this a /25. What is going to happen? What abomination am I going to create? All right, so let's take a look here, right? We know a /24 is 24 ones, so a /25 is, you guessed it, /25, 25 ones, all right? So let's do that out right now. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, that's 24 ones. 25, 1, and then 1, 2, 3, 4, 5, 6, 7. /25. Okay. So what's this in decimal? Well, we know this is 255. 255. 255. What's that? Well, if you just drop that into our binary conversion table, and have a 1 here in the 128 position, and all zeros, so 128. So my subnet mask now is 222.55.128. Oh boy, what are we doing? All right, so let's keep going with this. All right, can we find our network address? Sure, why not? It's the same process. We just change the subnet mask. Again, the subnet mask is just the scope of the address. Where does it begin? Where does it end? All right. We've now changed that by changing the subnet mask, by taking a bit that was once part of the host, so a /24, right? If we take that /24 and we take one of these bits and we give it over here to the network portion from the host, we now only have 7 bits here in our host portion of our address. So let's take a look at what that actually means. All right. So we can find our network, right? That's the same, that's the same, that's the same, right? So 1, 1, 1, 2, 3, 4, 5, 6. 1, 0, 1, 0, 1, 0, 0, 0. 0, 0, 1, 1, 0, 0, 1, 0. That's nothing new, right? These 3 octets are the same, right? Just like a /24. But, like that, right? Let's go out here, okay? This one is right there, okay? So this, you know, we're gonna compare here, right? This line is now kind of shifted over 1, right? Kind of shift the line over, all right, for our network boundary, all right? But we're going to do a 1 to a 0, right? And then we have 0, 0, 0, right? 3, 4, 5, 6, 7, 8. And actually, let me redraw this this dotted line, okay? It's a bad representation. I kind of screwed this up. All right, give me a second here. Let me fix this. I can fix this, I swear. Okay. So that's 1, 2, 3, 4, 5, 6, 7, 8 dot. And then 1, 2, 3, 4, 5, 6, 7, 8. All right. So our boundary, I'm still messed up here, aren't I? Oh, that was a bad move, Andrew. And all right. Again, our new boundary for this network is right here. And I'm going to kind of just squeeze it out there. All right. So again, that is our new boundary line. So we still have a 192, 168, 50.0, but our network's boundary location has changed. We're no longer, all of this, these 25 bits here is the network, and these 7 bits here are the host. So what is that going to mean for us? Well, let's keep going, and we'll find out what this really looks like. All right. If we have a broadcast, okay, and all of this gets flipped, you know, all of this comes down, all right, And I'm actually not going to write out the binary again for all this. You've seen this a bunch of times. 192, 168, 50. But I will write the binary here. All right. Dot. And we have a 0. Remember this 0 right here? This comes straight down there, right? That 0 comes down, but we only flip the host bits, all right? So 0, 1, 2, 3, 4, 5, 6, 7. All right, that's 7 host bits. We don't have 8 host bits anymore, we have 7, all right? So what's this in binary? Well, if you put that all through the table, actually do that if you wanted to pause the video right now and you wanted to go through and do that, you would actually find out that we get a value of 127. All right. We still have to include this, right? When we go through the binary, don't get caught up there. We still have to include that 0 because it's part of the entire octet. But that boundary, right? This /25 has radically changed our address, right? Again, 1s represent network bits, 0s represent host bits. I've got 7 host bits, all right? So I can only flip 7 of them, but all 7 of these plus that 0 still exist within this octet, all right? So this 0 is 128. These added up all together, 64, 32, 16, 8, 4, 2, 1. All added up together gives me 127. So my new range, right? My new range of addresses is first, last, right? 192, 192, 168, 168, 50, 50. Well, 1, but minus 127, yeah, that's 126. All right, and coming down here, finally, looking at our value here, we have 2 raised to the not 8 anymore, we have 7. That's 128. Okay, we're going to see this come back in the future. Minus our 2, 126 total hosts for this network. So if we're looking for a network that has, you know, about 100. Now, this is never going to be an exact science. We're kind of going to look at this, we're going to go, I need about 100 hosts. What's the smallest network that I can make that's going to fit 100 hosts in it? /25 in this case, right? We're going to see, and looking in the next example, if we go to a /26, this might change a little bit. And our network, that's going to change too. All right. So looking at this, we don't have to just subnet on that /24, that /16. We can start moving these host bits back and forth. And we're going to find that as we move the host bits to the right, our networks get smaller and smaller and smaller. And as we get smaller and smaller, we get even more networks, right? For every, you know, we're going to create more networks, but they're going to be smaller, right? And if we, instead of borrowing a bit and giving it to the network portion on the right here, what happens if we made this like 0, 0 like that? We would have 9 zeros. What if we had 9 host bits, all right? We'd actually start to see the networks get even bigger, but we'd have less of them. And that's reminiscent if we look back a few videos where a /8 had a network of 16 million, but there was only 128, you know, networks total. Whereas a a Class C network could have 254, but there was over 2 million networks, all right? So we're going to be able to start to slide this back and forth to manipulate the size of our networks to suit our needs. So in the next video, we're going to look at another example of this, and we're going to change that 25 to a 26.